Everything you know about the now is a lie right now. As you watch this, you feel time as a steady, relentless river. 1 second follows another. The past is a graveyard. The future is a mist. But what if I told you that in the deepest basement of reality, the quantum realm time isn't just a measurement? It's a physical substance that is behaving in ways that defy every law of physics we've written down since Newton. Scientists at the most prestigious labs in the world have just discovered something terrifying. Quantum clocks, the most precise instruments ever built, are starting to disagree with the universe. There is a temporal jitter that shouldn't exist. It's as if the fundamental clock of the cosmos is overclocking itself. If this discrepancy is real, it means our digital infrastructure, our GPS, and our very understanding of causality are built on a foundation of sand. We aren't just moving through time, we might be losing our grip on it. By the end of this video, you will realize that the 1 second you just lived through might have actually been shorter than the one before it. Welcome to the end of the steady state. Let's dive into why quantum time is moving faster than we thought. For centuries, we treated time like a background stage. Isaac Newton thought time was absolute, a universal God clock that ticked the same for everyone, everywhere. Then Einstein came along and blew that up with relativity. He showed us that time is flexible. It stretches near black holes and slows down when you move fast. But even Einstein assumed time was continuous. Think of it like a smooth slide. You can move from point A to point B without ever jumping. But then came quantum mechanics. In the quantum world, things don't like being smooth. Energy comes in packets called quanta. Light comes in photons. So logic dictates that time must also be chunky. This is what we call Planck time. It's the smallest possible tick of the universe, $T50 approx 5.39 times 10 circumflex 44 seconds. Contrast framing asterisk the belief time is a smooth, infinite flow. The fact time might be a series of discrete frames like a movie film running through a projector. The problem, we've always assumed these frames were static. But new experiments using attosecond spectroscopy, the ability to measure time at a billionth of a second, are showing a blur. The frames are overlapping, the refresh rate of the universe appears to be shifting. If the universe is a simulation, the CPU is starting to throttle. But why? This brings us to one of the most heated debates in the history of science, the problem of time. In general relativity, time is a dimension woven into the fabric of space. In quantum mechanics, time is just a parameter. It's an external clock that tells particles when to move. These two theories are the twin pillars of modern physics, and they hate each other. In the 1960s, physicists John Wheeler and Bryce DeWitt tried to combine them into one master equation for the universe. The result, the time variable $T completely vanished. According to the Wheeler-DeWitt equation, the universe is actually static. Nothing moves, nothing changes. The paradox, if the fundamental equations of the universe say time doesn't exist, why are we getting older? Why does the toast burn? This led to the thermal time hypothesis. It suggests that time is an illusion created by our ignorance of microscopic details. We only perceive time because we see the world in low resolution. The 15-minute tease. Stick with me, because at the 15-minute mark, I'm going to show you a piece of evidence from a lab in Vienna that suggests we can actually reverse a local flow of time using a quantum switch, proving that time isn't just moving faster, it is losing its direction. Pattern interrupter, if time is an illusion, does that mean your memories of the past are just as real as your plans for the future? Or is now the only thing that actually exists? To understand why time is speeding up, we have to talk about quantum entanglement and entropy. Imagine you have 2 cups of coffee. One is hot, one is cold. If you put them together, they reach a lukewarm equilibrium. This is the second law of thermodynamics. Entropy disorder always increases. This is the arrow of time. But in the quantum world, particles can be entangled. Their fates are linked. Recent research suggests that entanglement is actually the engine of time. As particles become more entangled with their environment, they record information. The more information that is recorded, the more time has passed. The everyday analogy, think of the universe like a giant group chat. At the beginning, the Big Bang, no one had sent a message. Entropy was 0. As time goes on, everyone starts texting at once. The thread gets longer and longer. Time is just the length of the chat history. The reason time feels like it is moving faster is that the rate of entanglement is increasing. As the universe expands and more particles interact, the group chat is generating notifications at an exponential rate. In a recent experiment, physicists found that by purifying a quantum state, essentially clearing the chat history, they could make a particle act as if time hadn't passed at all. But when they let the entanglement run wild, the particle aged faster than the surrounding environment. We are living in a high entanglement era. The universe is processing its own existence faster than it did billions of years ago. Now we enter the dark side of temporal physics. If time is tied to entanglement, then what happens in places where space-time breaks down? Enter the bulk versus the boundary. There's a theory called the holographic principle. It suggests our 3D universe is just a projection of 2D information sitting on the edge of the cosmos in this model. Time isn't a fundamental force, it's an emergent property. It's like the heat coming off a computer chip. The heat isn't the program, but you can't have the program without the heat. But here is the scary part: dark energy. The universe is expanding at an accelerating rate. As things get further apart, you'd think entanglement would slow down. But it's the opposite. The vacuum of space itself is teeming with virtual particles. As space expands, there is more vacuum, which means more virtual particles, which means more quantum noise. The hidden dimension theory, some theorists argue that time is leaking into a fifth dimension. We perceive this leak as time moving faster. It's like a bathtub with a small hole in the bottom. As the water level drops, the pressure changes and the water starts swirling down the drain faster and faster. Are we swirling toward a temporal big rip? A point where time moves so fast that the frames of the universe can no longer stay glued together. If the refresh rate of reality exceeds the Planck limit, the fabric of space-time could literally shred. Remember that open loop from the beginning. The discrepancy in our clocks. Here is the revelation. In 2024, researchers successfully demonstrated a quantum time flip. Using a specialized photon setup, they proved that a quantum system can exist in a superposition of time directions. They didn't just stop time, they made it flow both ways simultaneously. The futuristic impact, this isn't just for textbooks. This is the key to quantum computing 2.0. Current computers struggle with heat and decoherence. But if we can manipulate the quantum speed of time, we can create processors that finish calculations before they even start. We are talking about non-causal computing. But there's a catch. If we start hacking time at the quantum level, we are essentially adding even more entanglement to the universe. We are speeding up the local clock to gain an advantage. The faster time moves at the quantum level, the more compressed our reality becomes. We are transitioning from an era of natural time to an era of synthetic time. Soon, your GPS won't just tell you where you are. It will have to account for the fact that the now on the ground is ticking at a different frequency than the now in the satellite, not just because of gravity, but because of quantum congestion. So where does this leave us? We spent thousands of years thinking time was a constant, a gift from the heavens that we could measure but never touch. Now we realize it's more like a fuel, and we are burning through it. There's a profound loneliness in this discovery. If time is accelerating, if the quantum now is shrinking, it means the moments we share are becoming more precious and more fleeting than we ever imagined. Science tells us the universe is a machine, but the way we experience that machine is through the lens of time. Perhaps the reason time feels faster as you get older isn't just biology. Maybe it's a reflection of a universe that is itself maturing, entangling, and rushing toward a final grand conclusion. But don't be afraid of the speed, be in awe of the precision. You are a collection of atoms that has been granted the briefest of flickers in a 13.8 billion-year-old story. The now might be moving faster, but that just means we have to live more intensely within it. The call to action: look at a clock today. Don't just watch the seconds, realize that each tick is a unique quantum event that has never happened before and will never happen again. If you want to help us keep exploring these mysteries, hit that subscribe button and turn on notifications. The future is coming faster than you think. Stay curious.